Hello friends, let's start this session with fractions, decimal and percentage. So in this session I'm going to tell you the fastest technique for doing the fractions, decimals and percentage sums. Okay, so first concept in this I'm going to tell you is called auxiliary fraction. Okay, and I'll explain what exactly the meaning of auxiliary fraction. After that I'll tell you the percentage technique. Okay, how to find the percentage of the any number in a very quick session. And the third concept I'm going to tell you, we are going to discuss the recurring decimal, and we are going to see how to convert those recurring decimals into the fractions. Okay, so as we know that, let's start with this first, auxiliary fraction. As we know that we have, uh, when we talk about fraction, right, it's generally of two types: proper fraction and improper fraction, right? So in the proper fraction, as we know that it's less than 1, and the improper fraction is greater than 1. Why? Because in the proper fraction, our numerator is less than denominator, and in the improper fraction, numerator is greater than denominator, right? So think about think about a fraction like 5 by 7. Okay, so 5 by 7 is obviously it's a proper one, right? Correct. So what is the definition of auxiliary fraction? Every proper fraction having last digit 9 in the denominator are called auxiliary fraction. You can write it down. So auxiliary fraction is a fraction where in the denominator last digit 9. Okay, and if you don't have 9, if you can convert that in 9, even that will be called auxiliary fraction. I mean to say, suppose 1 by 9, 2 by 19, 3 by 29, 4 by 119, right? You see, these all are proper fraction only, right? And in the denominator we have the last digit 9, you see, right? So our agenda is to convert all these fractions into the percentage. As we know that percentage can be like, if you have any fraction, right, if you want to convert this in percentage, so simply we have to multiply by 100. Okay, so this technique I'm not going to use. I'm going to use quite different technique for this, basically auxiliary fraction. Okay, let's have one sum. Okay, so I'm just doing it here. Okay, let's let's talk about uh, 4 by 19. Okay, 4 by 19, how much in percentage I'm going to show you. Okay, so 4 by 19, I'll write approximately 4 by, I'll add extra 1 to this 19, so I'm using this approximate sign, and then I'm writing 4 by 20. Then I'm breaking this 20 like this, 10 into 2, I'm writing this 4 by 10 as 0.4, and then I'm writing this 2. Okay, so we have 0.4 by 2. Now we will write this 0 point as it is. We'll divide this 4 by 2, so we have quotient as 2, remainder as 0. So I'll write the remainder 0. So we have now 0 2 will be divided by this 2. So quotient is 1, remainder is 0. Now we have 0 1 divided by 2, this 2 again. So quotient is 0, remainder is 1. Now we have 1 0 divided by 2. Quotient is 5, remainder is 0. Right, and so on and so forth. Means if you keep doing this, you'll get 0.2105. Okay, dot dot dot. Uh, so if you multiply this with 100, right, so you'll get, this point will shift to after 2 digits, right? So it will become 21.05 percentage. See how easy and how amazing it is, right? Correct. So every see why I'm telling you this, because if you do any business maths, like if you solve your profit and loss, if you solve your simple interest, compound interest, you'll have this kind of fractions. you'll have the percentage questions coming in between. So you can write quickly, as quick as like 4 by 19 direct, you can write 21.05, right? As we know that 1 by 2 is 50%, right? In a similar way, 4 by 19 we can write 21.05. So you have to make a table for this auxiliary fraction to use it. Okay, let's have another one. Okay, i'm just uh, I'm just rubbing the upper portion and I'm just writing another sum. Okay, so let's take this time 13 13 divided by 79. Okay, cool, right? So in the 1379 approximately I'll write 13 by, I'll add 1, 79 plus 1. So 13, why I'm adding 1? Because there is, means this denominator, if you add 1, there is no big changes you're going to see, so we can add 1. Okay, so this is 80, so 30, 80 will become 10 into 8, then this 30 by 10, 30 by 10 is 1.3 divided by 8, then we'll write, see 1.3 is lesser than 8, right? So what we'll write, we'll write 0 point, then it will become 30, 13 by 8, quotient is 1, remainder is 5, so we have 51, 51 by 8, quotient is 4, sorry, quotient is 6, remainder is 3, we have 36, 36 by 8, quotient is 4, remainder is 4, 44 by 8, quotient is 5, remainder is 4, 45 by 8, quotient is 5, remainder is 5, right? You see, so we have now this one, so we have 0.16455. So if you multiply this with 100, so you're getting 16.455 percentage, right? Clear, right? Okay, so that's how you have to do this. Okay, so in this table of yours of auxiliary fraction, you can write 13 by 9, 13 by 79 is equals to, it's not approximate then, okay, it's equals to 16.455 percentage. 4 by 19 is equals to 21.05 percentage. In this way, you can find other values like 2 by 19, 3 by 119, whatever value you wish to have, you can find it, right? So this is about auxiliary fraction. Now let's go and do the sums on percentage. Okay, so I'm telling you a very fast approach of percentage, how to find the sum on percentage. So I will totally go with sums. Okay, so let's discuss a business maths. So generally, if you go and see in your competitive maths exam, so there are a lot of questions coming from fraction, decimal, percentage, and so as I said, like uh, percentage is very much used. Okay, even in competitive exam, if you see, there are a lot of questions in the quant as well as in data interpretation. There will be a chart given where you have to compare with some data. They will be asking like what is the percentage increase or decrease of A with respect to B. So this kind of stuff, a lot of asked. Okay, so let's have one sum on percentage and calculate it. So suppose I'm giving one question. Suppose we have 76 uh, 76 liter, 76 rupees per liter. Okay, 76 rupees per liter is the price of the petrol. Okay, nowadays in India actually. So that's why I'm taking the price as rupees. Okay. Now due to government tariffs or some like government decisions, the price has been increased by 5%. Let's suppose. So we have to find the new price. Okay, by the technique I'm going to show you. Okay. So what you'll do? Let's see the new price. This 5%. What I'll do? This 5% I'll convert in decimal first. So 5 divided by 100, it will become 0.05. This 0.05 will be added to the 1. It will become 1 plus 0.05 means 1.05. Now this 1.05 will be directly multiplied to 76, means 1.05 into 76. Okay. So we can multiply this 1.05 with 76 with 3 cross 3 vertical crosswise method. Okay, and our answer is this. Our answer will be 79.8, right, by the 3 cross 3 vertical crosswise method. Okay, so right, so basically I have done this in a rough actually, 79.8. Okay, now see, this kind of process, this kind of approach you have to use. Okay, think about the scenario where uh, the the price is decreasing, right? Like suppose instead of increasing, it is decreasing by 5%. Okay, so what you'll do, you will zero point zero 0.05, this 0.05 will be subtracted to 1, subtracted by 1 means 1 minus 0.05, so which will give you how much? 0.95, right? Correct. This 0.95 will be multiplied with 76, and whatever the value will be coming, that you can do by vertical crosswise. You can see I'm just doing it here. Okay, so 6 into 5 30, 3 carry, then 54 and 35, then you are adding it, 89 plus 3 92, 2 9 carry, then 63 plus 9 72, and you're putting decimal here, so we have 72.20, right? So the final answer is 72.20, right? So this kind of fast approach you can use, okay, in your sums. Okay, so that you could do a lot of so many sums in a quick time. That is our focus is. Okay, now let's go and do uh, the last portion of this session. Like we are going to see how a recurring decimal can be converted into the fraction. Okay, I'm going to show you. Okay, let's have this. Okay, let's take a let's take a number let's take a number 0.3555 dot dot dot. So basically you can see that this dot dot dot, it's keep going, means it's non-terminating. Okay, so I'll consider this number as x is equal to 0.3555 dot dot dot. Okay, I have to convert this number. So basically this can be written as 0.35 and recurring, or it can be even written as 0.35 dot here. Okay, so now this particular value I have to convert in fraction. So what I'll do, I'll consider this x as 0.3555 dot dot dot. I'll mark this as equation number 1. I'll multiply uh, the first equation with 100. Okay, so I will write 100x is equal to, this point will shift to 2 decimal right side, so it will become 35.555 dot dot dot. I'll mark this as second equation. Okay, then after that I will multiply again with one extra zero, so this will become 1000x, and this will become 355.55 dot dot dot. I'll mark this as third equation. Okay, and I'll subtract this third equation minus second equation, so that will become, I mean to say 1000 minus 100, so that will become 900. X is equal to, I'll do the subtraction of 355.555 dot 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 with 35.555 dot dot dot. So you see these are zeros, so this is also 0, this is 2, and this is 3, so you're getting 320, and this side 900x, right? So x is equal to 320 divided by 900. You can make it you can make a smallest fraction, so it will become 32 by 90. You can make much 1645, so final answer is 16 by 45. Okay, so if you see 16 by 45 is equal to, then 0.3555 dot dot dot. Okay, see this 16 by 45 is a rational number. Okay, always remember, rational number is a number which is in the form of p by q, where p and q are integers, and not necessarily integers. P and q can be real numbers, and q cannot be 0. This is the condition of rational number. So every non-terminating, okay, this number can be converted into the rational number. Okay, in this case, in this way, right? So this is the lesson we discuss. So this was a very important lesson where we discuss fractions, decimal, and percentage, and that too the fastest approach. Okay, and I'm going to start algebra in the next class. I'll start with simultaneous equation, then I'll go into the quadratic and the cubic one. Okay, okay then. Bye. Take care. Good day.